Problem number 27. Use the chain rule for paths to compute the derivative of t of r of t with respect to time. At t is equal to 1, here's t, here's r of t. What does the chain rule for paths tell us to do? The derivative with respect to t of r of t is equal to the gradient of t evaluated at r of t dot product r prime of t. Okay, so now we just have to fill in all of the important pieces here. The gradient of t, the x partial derivative is 1, the y partial derivative is going to be 6y, the z partial derivative is e to the z. The gradient of t, oops, no hat there, evaluate at r of t is 1, 6y, y here is t cubed, t squared plus 3. And then e to the z is t to the 4th. We also need r prime of t. R prime of t is going to be 3, 2t, and 4t cubed. Now we could go ahead and calculate out this dot this, but first realize that we are being asked for this at t is equal to 1. So I'm going to go ahead and just compute both of these at t is equal to 1. So r prime of 1 is 3, 2 times 1 is 2, 4 times 1 cubed is 4, and the gradient of t evaluated at r of 1, plug in t is 1 up here, we get 1. 6 times 4 is 24, e to the 1 to the 4th is e. And so all we have left to do then is just to compute the gradient of t at r of 1 dot product r prime of 1, and that's going to be this dot this. And so this gives us what? 1 times 3 is 3, plus 24 times 2 is 48, plus 4e. So, okay, this one is a relatively straightforward application of the chain rule for paths. But let's do another relatively straightforward one, problem 28 here, from, again, the same section of the book. Find the directional derivative of this function in this direction at the point 1, oops, I miscopied this, 1 to negative 2 at that point. Okay, how do we tackle this? We are going to, the directional derivative we know is going to be the gradient of the function at this point dotted with a vector in this direction, but it needs to be a unit vector. So let's go ahead and start computing some things here. The gradient of f here is going to be 2x, 2y, and 6z. The gradient of f evaluate at the point 1 to negative 2 ends up as 2 times 1 is 2. 2 times 2 is 4. 6 times negative 2 is negative 12. So this is the gradient of this function here at the point in question. The next thing that we have going on here in the direction of v is 1, negative 1, 1. So u needs to be a unit vector here. I'll realize that the magnitude of v is square root 3. Check that for yourself. So u is 1 over square root 3 times 1, negative 1, 1. So all of this allows us to go ahead and just write down our final answer. So the directional derivative here is gradient f, evaluate the point 1 to negative 2, dot product u. So 2 for negative 112, dot product with 1 over square root 3 times 1, negative 1, 1. What do we end up with? 1 over square root 3 times 2 times 1 is 2, 4 times minus 1 is negative 4, negative 12 times negative 1 is negative 12. So this should be negative 14 over square root 3. So if we're, if we're at this point moving in this direction, we're actually decreasing. Our function is decreasing, moving in the direction of this vector at this point.